nearly 13 main topics. Today, first we will discuss introduction to econometrics, where you are going to learn the objective of econometrics and how to develop econometrics model. Once you complete today's session, you will learn how to construct or create econometrics model. Then there are many type of econometrics model. Then we will discuss the simple linear regression model. It is the simple model we can have. It is we call simple linear regression model. Then to estimate regression model, there are many estimation methods. We will learn one estimation method. It is called ordinary least square method. This is our third topic. Then once we estimate regression model, we will have to conduct a statistical test or significant test. And we will learn how to conduct hypothesis testing and confidence interval for regression model. This is our fourth topic. Then we will learn properties of least square estimate and the assumption of regression model. And also we will learn multiple regression model where we have more than one independent variable in the regression model. We estimate regression model with some assumptions. When these assumptions are violated or not satisfied, we have problems related to regression model. These are called autocorrelation, multicollinearity, heteroscedasticity. There are three main problems. Then we will learn the meaning of these three problems, as well as we will learn how to rectify or solution for these issues. And also we will discuss uh, another concept called dummy variables. The dummy variable is a technique which you can use to introduce qualitative variable into regression model. As an example, if you want to introduce uh, gender, male and female, into regression model, then you will have to use dummy variables. Then our 12th topic is cross-section regression model, where you are going to learn how to estimate regression model using cross-section data when Dependent variable is qualitative variable. There are two types of data, time series and cross section. Time series mean data collection, data are related to different time period, different years. Cross section mean the time is constant. That means it's for one time period from different individuals. Let's say as example, if you want to collect consumption data, time series mean consumption expenditure of, let's say, one country for different years, starting from 2023 to maybe 20 years or 30 years. It's a time series data. It's related to only one country but different years. Cross section means same values or consumption data you can collect from different countries related to one period. It is we call cross section. Then there are different type of regression techniques for cross section regression and time series regression. Then I will discuss cross section regression models. Then the time series regression models will be discussed by Professor Dunsingh. He will take nearly 5 or 6 sessions to discuss time series regression model. And also, we will introduce two different computer software for you, Stata and eViews. Both computer softwares are mainly for econometrics analysis. I will introduce Stata, then the eViews will be introduced by Professor Dunsingh. Okay, this is the content of this course module. And there are many econometrics books, but mainly my discussion is based on Introduction to Econometrics, Christopher Doty. This book is, if you want, you can buy this book. It's available in Sri Lanka also. And I think you can uh, download it from internet also. Okay, this is the content of the paper. Then for the assignment, I'll give one assignment for you, maybe a small group assignment. Mainly, you will have to run a regression model and interpret it. That is the your assignment. In detail, I will give later, but just the idea is once we learn these things, you should be able to run a regression model and interpret. I'm going to evaluate whether you can estimate the model and whether you can interpret the model. Okay, then if you have any concern about this content, you can raise before I move to next section. Then we will create LMS later, maybe in the next week, we will give access for LMS. Then meantime, I will share this document with you through the chat box. Okay, then we will move to introduction to econometrics. Here mainly we are going to learn how to develop econometrics model. Once we complete this discussion, you will learn how to construct a econometrics model. Then before we move to develop a econometrics model, we can have a discussion about what is econometrics. The econometrics deal with measurement of economic relationship. That means econometrics we have introduced or researchers has introduced to measure the economic relationship. Once you learn econometrics, you will be able to measure economic relationship. Actually, in the originally, it was introduced to measure economic relationship. But now we can see the econometrics techniques will use to measure any kind of relationship. In the social science, maybe uh, sociology, in the political science, and any field, they are using econometrics model to measure socio-economic relationship also. Not only economics, we can use econometrics model to measure social relationship also. Then econometrics is a combination of economic theory, mathematical economics, and statistics, but it is completely different from each one of these branches. That means econometrics is a combination of three subjects: economic theory, mathematical economics, and statistics. There are three main subjects. That means mainly we have developed technical econometrics to measure economic relations. That's why we have economic theory. Then to measure economic relationship, we should have a mathematical model. Mathematical model. Okay, we should have a mathematical model. Then once we create mathematical model using some statistic techniques, we can convert mathematical model into econometrics model. And also to estimate mathematical model, we will have to use concept or technique in statistics. Then this explain how these three subjects are combined. Now, if you take economic theory, it is a qualitative one. In pure economic theory, there is no any numbers. Economic is a social science where we can learn the relationship Uh, so yeah, we can learn some relationship between agents or individual in the economy. Then the most of economic theories are qualitative. Let's say, as a simple example, the law of demand, the law of demand, the law of demand. It is a qualitative concept. What is the law of demand? It says there is a negative relationship between price and quantity demand. When price increase, quantity demand decrease. When price decrease, quantity demand increase. It is the basic idea of law of demand. The demand for good is a function of price. There is no any mathematical thing. It's a qualitative statement. Then, if you want to measure this relationship, that means it says QD, demand, and price. There is a negative relationship. Now, if you want to see whether this relationship is actually we have a negative relationship, then you can collect some data and also you can derive a mathematical model to measure the relationship between these two variables. What is the simple mathematical model? You can say y equal m x plus c. This is a linear model. Y equal m plus x plus c. What is the m? M is the intercept. C is the slope. Then this is a linear model, simple linear model. Then this mathematical model you can use to explain theory of law of demand. Then you can say QD is a function of P. And this relationship you can explain using QD equal A minus BP. QD is quantity demand, P is price. A is intercept, B is slope. Then using this mathematical model, you can explain the law of demand. If the law of demand is exit, then the value of or sign of B should be minus. A is quantity demand when price equal to zero. Then the B shows the slope. This is we call mathematical model. Then these mathematical model, actually mathematician, they introduced this model. But The estimate this model is not a task of mathematician. The estimate of this model is a task of it's a task of econometrician. Okay, the mathematicians they introduce mathematical model. That's why you can see in the microeconomics and macroeconomics there are many mathematical models or equations. All these equations are from mathematics. Because later uh, in the economic, that means the thought, that means how the subject of economics evaluate, then most of uh, economics are from engineering background. They have good mathematical background. Then they have used mathematical model to uh, explain the economic relationship. Later, econometricians have estimated these mathematical model using econometrics concept. For that one, they have used the techniques in statistics, maybe data collecting, processing, and presenting. These are the three main activity in statistics we learn for stat course module. But beyond that, there are some estimation method in statistics. We learn hypothesis testing, and also we learn confidence interval using these concepts. Econometrician has developed econometrics model. I hope now you may have idea about these three subjects. Okay, then we will move to discussion about how to develop econometrics model. These are the main steps you have to follow if you are going to uh, construct econometrics model. It start with the economic theory. Sometime you can start it with sociological theory also. It should be a statement or theory or hypothesis. It may be related to economic or maybe sociology or maybe political science, maybe international relation or any subject. But there should be some theory or hypothesis behind your econometrics model. You can develop your model based on theory and hypothesis. Then you will have to develop mathematical model to explain the theory you have selected. Then the mathematical model you have to convert into economics model. Then you will have to collect the data and estimate the parameters in your regression model. And also hypothesis testing, prediction, and policy purposes. These are the key steps you have to follow if you want to construct a econometrics model. Then I will explain all these steps using simple example. Okay, simple example. Then first you'll have to find theory or hypothesis. Now here in this example, we have used theory from macroeconomics. Theory from macroeconomics. You have learned macroeconomics in semester 1. There are many theories you have learned. Among these theories, Keynesian theory of consumption is the one important theory which you can use to explain the relationship between consumption and income. The Keynesian theory explains the relationship between consumption and income. According to the Keynes, there is a positive relationship between consumption and income. That means when income increase, consumption also increase. But consumption not increase as much as income increase. That means if income increase by 10%, consumption will increase, but not by 10%, less than 10%. That is the main idea of Keynesian theory. You can consider it as a hypothesis or theory. Then, as a researcher, now you want to test whether this theory is applicable to explain consumption and income in a selected country or maybe in a selected society. Okay. Then, uh, then to test this one, you will have to develop a mathematical model. First, you will have to develop a mathematical model. Then, the simple mathematical model you can use is y equal beta 1 plus beta 2x. It is a simple mathematical model. Here y is consumption expenditure, x is income. Then beta 1 we can say intersect. Beta 2 is the slope of coefficient, beta 1 and beta 2. And also beta 2 we can interpret as the MPC, marginal propensity to consumption, MPC. The meaning or the how, what is the MPC? You have learned for your macroeconomics. It is, let's say, changing consumption divided by changing income. It's a simple definition for marginal propensity to consumption. Then in this model, beta 2 shows MPC. Now you can see in this model, you can see you have assumed consumption is only a function of income. Consumption is a function of only one. That means there is an assumption. We have assumed consumption is only depend on income. If you take real situation or practical situation, you know consumption is not only depend income, it depend on many other factors. What are the other factors which determine consumption expenditure? There are many other factors, maybe size of family, maybe age of members in family or family religion. Like this, there may be many other factors which determine consumption expenditure. But in your regression model, you have assumed it only depend on income. If it is not only depend on income, then we can say the relationship between economic variables are inexact. The meaning of inexact is that the variable, our dependent variable, is consumption. It is not only depend on one factor, it will depend on many other factors. Okay, it will depend on many other factors. But when you develop mathematical model, you have assumed it depend on only one factor. But it is not true. Then when you convert your econometrics model, when you convert your mathematical model, this is the mathematical model, only one variable. When you convert mathematical model into econometrics model, you have to consider all other independent variables which are not included in mathematical model. Then to take into account all these variables, we introduce one component. It is we call error term, or maybe disturbance terms in our regression model. Once you add error term or disturbance terms to econometrics model, to mathematical model, it will become econometrics model. It will become econometrics model. Then in the econometrics model, error term has some properties or probabilistic properties. Then later, we will discuss the properties related to error term. Once these properties related to error term violate, then we have problems in econometrics model. Okay, then the disturbance term mainly will represent all the factors that affect consumption but explicit. Hello. Please,
දාගන්න මේක. අන්න කටේ දාගන්න අච්චි. මම දුවනේ. චූටි මට කියන දේ අහනවා. චූටි මගේ දුවනේ.
please mute your microphone. Okay. මල් කඩන වෙලාව නේද? Yes, okay. Then okay, then I can use this diagram to explain the concept of error term. Now here you can see two variables x and y. X is income, y is consumption. Or x is our independent variable, y is our dependent variable. Consumption is depend on income. Now you want to estimate this model. You have data related to x and y. X is income, y is consumption. Then I can select 10 students from this class. We have 32 students. Let's say I select 10 students. I can ask their income, okay, and consumption. Let's say one say income 100,000, the consumption expenditure may be 70,000, like this. I can collect data from sample. Let's assume our sample is 10. Okay. Then according to our sample data, one students as income x1. If the income is x1, the consumption expenditure is y1. This is the actual figure. He has income x1, the consumption is this one. Another individual or another student says income is x2, consumption is y2. Like this, you can collect data. These are actual values. The dot shows the actual values. I hope you got the point. Actual values. Then using these actual values, we can develop econometrics model. Later, we will learn actually how to do it. Just assume you estimate the model. According to the model, according to the model, according to the model, this line shows the relationship between income and consumption. According to the model, this line shows the relationship between income and consumption. Now, actual situation, if income is x1, the consumption is y1. Consumption is y1. But according to the regression model, if income is x1, the consumption expenditure is somewhere here. This y1, we can say this is y1 hat. The y1 hat mean predicted value. Here y mean observe value or actual value. Now you can see there is a difference between y. y1 mean this value. Then we can say it is yi because there are many y values. yi mean it may be y1, 2, 3 like this. The difference between yi and y hat I is we call error term. Error term. Okay, error term. The difference between actual value and the predicted value is we call error term. Then in the regression model, the error term represent the, the factors which are not included in regression model. If you can include all factors into your regression model, then you can reduce the error term. It may not possible to have a zero error term, but for the certain level, you can reduce your error term if you can introduce all determinants of your dependent variable. Now in this model, as we have introduced only one variable, then the difference between yi and y hat is we call error term. I hope you got the point. Then now we have developed our regression model. The regression model is this. Then the next step is collect the data. Then you can collect the data from, as I explained earlier, if you want, you can collect data from cross section. Now, from this MFE group, if you want, you can collect the data, okay, about their income and consumption expenditure. Now we have 32, 31 students. If you collect data from, let's say, about 30 students, you can ask what is your last month income and expenditure, consumption expenditure. Then using these data, you can estimate consumption function. But in this example, we have used time series data related to hypothetical country. The income we consider as a GDP, gross domestic product. The consumption is personal consumption expenditure. Personal consumption expenditure. All the data are in real term. That means we can have value in nominal value and real value. GDP we can calculate for real value and nominal value. Real value means we have removed the inflation from the values. Now using these data, you can estimate the regression model. Now this shows the estimated regression model with observed value and the predicted value. Then the observed values are the actual value. Some values are on the regression line, some are deviate from regression model. Now, the model estimation mean estimate the value for beta 1 and beta 2. In the next session, I will explain how to get value for beta 1 and beta 2, but just assume using this data, we estimate model and value of beta 1 and value of beta 2 is here. Then the value of beta 1 is the intercept, the value of beta 2 is the slope. Then we know here slope mean MPC or marginal propensity to consumption. It is around 70% or 0.7. It says that if income increase by $1, the consumption will be increased by 0.7 cents. Then the value of intercept shows the amount of consumption expenditure when income is zero. When income is zero. Then actually why we construct this regression model? What is our purpose? Our purpose is to test whether Keynesian consumption theory is whether it is applicable or not. Now, according to the Keynesian theory, MPC should be less than or equal 1. Less than or equal 1. Now, value shows it is 0.7. Our regression estimation shows it is 0.7. But you can't accept this as it is. You will have to conduct a hypothesis testing to test whether this value is significantly less than 0. Then you can construct null hypothesis. Then your null hypothesis is marginal MPC or beta 2 is less than or equal 1. It is your null. Because according to the Keynes theory, it should be less than or equal 1. Then your alternative is beta 2 should be greater than 1. Beta 2 should be greater than 1. Then if you can accept this one, that means Keynesian theory of consumption is applicable to explain the, the relationship between consumption and expenditure. If you are not accept this, that means Keynesian theory is not applicable. It is we call hypothesis testing. We learn for statistics, same technique we can use here. Okay, hypothesis testing. Okay. And also, once you develop model, you can use the model for forecasting or prediction. You can use the model for forecasting or prediction. Now let's say as example, if you want to predict consumption in year 1997, the GDP value of 1997 is assume this much. If the GDP is this value, then you can predict value of consumption. It is 4,951. 4,951. Then this is the predicted value. Okay. Then sometime with the data, you can see the observed value. The observed value or actual value may be this one. The predicted value is this. That means there is a difference between actual value and predicted value. The predicted value is higher than actual value. Then we can say it is over predicted. Over predicted. The difference between these is 0.37.82. Okay. Then if you consider it as a percentage of GDP in 1997, it is 0.76, very small amount. And once you construct the model, then you can use your model for policy purposes. You can use the model for policy purpose. Then, according to the macroeconomic theory, you have learned income multiplier. You have learned income multiplier or investment multiplier. It is equal this equation. Then the MPC is beta 2. Then M or income multiplier is equal 1 minus beta 2. 1 over 1 minus beta. Then the value of beta 2 we estimated. Then the multiplier value is 3.33, which shows that if investment increase by $1, income will increase by 3.33. Okay. Then based on this multiplier, we can have some policy implication. Now let's say you assume if the consumption level is 4,900, then you can assume the unemployment rate will be 4.2. If the consumption expenditure is 4,900, you can maintain unemployment rate at 4.2. Then you can find what should be the income. What should be the income? If the consumption is this much, the income should be this value. The income should be this value. Okay. Then like this, you can use your econometrics model for policy purposes. This is the way to construct econometrics model and interpret and use for policy purposes. Actually, today I gave an overview of econometrics model. Then next week we will learn how to estimate this model. That means now you have a simple idea about how to construct the model. That means up to this point you can do. That means you can identify a theory and you can identify a mathematical model and you can convert into econometrics model. These three concepts or steps you can do. Data collection also you can do. Then in the next session, I will explain how to estimate these parameters. Today I just saw some values, but you don't know how to get these values. Then I will explain how to get these values. That means these values mean beta 1 and beta 2. And once we get beta 1 and beta 2, you will have to conduct hypothesis testing. That we will learn later. And the prediction also we will learn later. Then once you estimate the model policy purposes, it is actually, you can do it, you can identify the possible policy implication. Okay, then the objective of today's session is to give a brief idea about econometrics model, how we develop the model, and how we estimate and interpret. I hope I explain it in a quite good way. Then the end of today discussion. Then in the next week we will discuss how to estimate the model, and later we will learn hypothesis testing, forecasting, and all these sessions. Okay, then if you have any questions, you can raise. Otherwise, I'm going to wind up the session because I start the lecturing at, and this is the third session. Then I'm also a little bit very tired. Then you also may be tired. You have start at early morning. Then okay, then if you have any question, you can raise. Otherwise, I'm going to wind up the session. Then